Good evening, guys. It's Monday night, and I'm here with the lesson for tomorrow, Tuesday, March 31st. This is what I'm going to do. Just to give time to the other kids to join in, the platform and to keep up with the homework. I'm going to do this lesson for tomorrow, but you don't have to give me the homework until Wednesday, or I will say Thursday, because I'm going to give you 2 days to work in the lesson. So you're going to work on this tomorrow, Thursday, and Wednesday. So you can hand it in the homework until Thursday, okay? And the next lesson is going to be on Wednesday, and that homework you can hand it in on Friday. So I'm going to be using 2 days for the next two lessons. So today we're going to do quadratic and linear systems, okay? We have to solve them using substitution first. But before that, I'm going to do now with you together that, like I'm always do that at the beginning of each lesson. And again, the topic today is solving quadratic and linear systems using substitution. Wednesday, we're going to do the same thing, but we're going to use elimination. Okay, so remember, we did substitution before with system of linears. Okay, today we're going to do quadratic and a linear equation. So the do now that I have for you, it was the following. Okay, solve for x using substitution. So I give you a hint. Okay, apparently you're supposed to do this during the classroom, right? But since we already doing the lesson online, so we have to do it together. So if you notice, the lesson I'm already started for you. So what I'm asking you to do is set the equation equal to 0, factor, and solve. Remember, this is a system of quadratic and a line. If you notice, okay, this one right here is a quadratic because it has the square. And this right here is a line because it has the linear term, which is x to the first, right? So remember, this is a quadratic and this is a line. So what we need to do, we have to find the value of x and the value of y, okay, that is part of this system of equations, okay? So those other pairs are supposed to be a solution for both, for the parabola, or should I say the quadratic, and the line. So when you have something like this, guys, okay, if you notice, these two y's are already isolated. So you can just put them in the calculator and graph them. That's what we're going to do down the road. But we're going to solve algebraically. So what I'm trying to do is, when you have something like this, what you do is a substitution, okay? Remember, this y and this y's are the same. Therefore, if I want to substitute this y, I can substitute this value for all this value right here. So this is what I did. I'm leading you step by step. So what I did is I wrote my equations, okay, on the bottom right here. And this y, right, this y right here becomes all this right there because I'm using substitution, okay? So this y becomes x squared minus 4x plus 3 equals x minus 1, which was already the value of the other equation. So now that I have those equal to each other, okay, I usually say to you guys, when you have the two values, two y's isolated or two variables isolated, just set them equal to each other, okay? But in this case, it's the same thing as saying substitution because I'm substituting this y for that part right there of the first equation. So when I put them equal to each other, then I solve for set it equal to 0. So that means that this x and this one is supposed to come to the left side, okay? We have to bring it to the quadratic side. And if this x is plus, it becomes minus, and that minus becomes plus. So remember, what I do here, I do on the other side too. So when I combine line terms, my x squared remains the same. When I combine these two, I get negative 5x plus 4, because 3 plus 1 is 4, equal 0, okay? That's the first step you have to do. Set it equal to 0. Now we have to factor. That is one of the easiest form to factor because the only thing I have to do is do double bubble, right? So I open my parentheses, and because the last term is positive, both parentheses have the same sign. So they're both going to have negative because that is the sign of the middle term. Remember that, okay? And now 1x here and 1x there, and I ask to myself, 2 factors of 4 that when I add them will give you 5. So it's 4 times 1 because negative 4 times negative 1 becomes positive 4, and negative 4 plus negative 1 is negative 5. So those are my 2 factors. Now what do? We do the t-chart, okay? And I set each set of parentheses equal to 0. All right. Now I solve for x. So that becomes plus 4 plus 4. So my first root is 4. Same thing on the other side, okay? Plus 1 because that was minus. X becomes positive 1. Now that I have my values of x, okay, I'm going to find my values of y. And to find the values of y, okay, guys, remember, you always pick the linear equation, okay? Always pick this one. You can pick either one, but that will be easier because you have less terms, all right? So I'm going to pick that what I wrote here, pick line to find y. And first I'm going to use the value of x when x equals 4 and the value of x when x equals 1. I will do that after. So you do what you're going to do one at a time. Remember, for each root, you still have to have a partner on y. So to find y, I'm going to write my equation because I'm using my linear equation. And I substitute x for 4 because that's the value of 4, okay? I mean of x, minus 1. That gives me y equals 3. Then I do the same thing with my other root. When x is 1, I'm going to substitute into my equation, okay? And that x becomes 1, and y minus 1 equals 0. So now I have my 2 values of y. So what I'm doing now, I'm going to write those solutions as an order pair, all right? So my first solution should be 4, 3, and my next one should be 1, 0. That means that those the equation of those two, the graph of those two equations intersect at those 2 points. Remember, when we do quadratic, that's going to be a parabola, and that's going to be a line. So the parabola and the line are going to cross into these 2 points, all right? So I always ask you, in class to check, all right? So we're going to do one just for you to remember how to check, all right? So to check, what I'm going to do, this. Remember, guys, you don't have to do this on the homework, okay? I'm going to use the 2 points. Remember, that's my first point, 4, 3, and 1, 0. So it has to work for both equations. So I'm going to do, okay, the first one first, okay? When x equals 4. So what I do is, that's my x value, and that's my value of y. So I'm going to use the parabola first, the quadratic. So this y becomes 3, all right? So I substitute that for 3 equals, the value of x is 4, so that x becomes 4 squared minus 4 from the equation, parenthesis 4, which is my value of x, plus 3. Whatever I see in x, I'm going to exchange it for 4. Now I'm going to start solving. 3 equals 16, sorry, I don't want you to look that, minus 16 because 4 times 4 is 16, plus 3. 3 remains in that sign. 16 minus 16 is 0, plus 3, and 0 plus 3 is 3. So that works. Also, it has to work for the line. So the line is y equals x minus 1. So y becomes 3 equals x, which is 4 minus 1, and 4 minus 1 is 3, and 3 equals 3. So that works, okay? So the other point also has to work. So we're going to do the same thing, all right? So now here, that's the same equation, right, guys? Because it's the same system. The y becomes 0. My x is 1. So 1 squared minus 4 times 1 plus 3. Remember, whatever I see in x, that becomes 1. Okay? So now, 1 squared is 1. Negative 4 times 1 is negative 4 plus 3. 0 equals, because remember, this side has to be equal to this side. That's what I'm trying to prove, all right? 1 minus 4 is negative 3. Remember, PEMDAS, left to right, when you do addition and subtraction together. And if you do 3 minus 3, that gives you 0, and that works. Same thing with the equation of a line. Okay, y becomes 0, x is 1, minus 1, and y minus 1 equals 0. So this is the process, okay, to do a system linear quadratic using substitution. It's a little lengthy, okay? Remember, and I'm going to ask you to check. You don't have to check on the homework, but I always like to do one for you guys to remember, okay, how to check. So let's do now a few more problems, okay? Because that's what we do now. I know it was kind of hard, but you know, I always like to make you think. So let's go to the second problem. Remember, guys, I have everything already done for you. I just want to write it over, so this way I don't waste too much time. And my instruction says solve using, okay, substitution. Remember, from now on, I'm going to tell you the phrase set equal to each other. So remember, when we have already, like in this problem, okay, if you notice, both y's are already isolated, okay? So that means that you can use substitution, but the clue word will be set them equal to each other. But remember, they both have to be isolated. When they both, when you have the y equals to something, that means that they're going to be the same. But in the reference sheet that I'm going to download to the lesson, it shows you this way. So that's what I'm trying to tell you, because I want you to understand what substitution means. So what it means is that this y right here, okay, is going to become this part right here. It's going to become the quadratic. So I'm going to write x squared plus 2x minus 1 equals, okay, 3x plus 3. All right, I'm sorry, 3x plus 5. All right. So it's the same thing as saying set them equal to each other. Substituting, that's what it means. Set equal to each other when both y's are isolated. So what I'm going to do, I'm going to set them equal to 0. So remember, I'm going to do 2 steps at once, okay? And I'm going to do 1 step at a time, because guys, you should know that already, right? We're killing 2 birds with the same stone. So when I do that, of course, I'm going to have 0 on this side, and I'm going to just combine here. The x squared remains alone because there has nothing to combine with. 2 minus 3 is going to give you negative x, and negative 1 minus 5 will give you negative 6. Now, factor, you know, double bubble, because this one is negative. Remember, when the last one is negative, you need 1 of each, 1 minus and 1 plus. The order, it does not matter, because what is important is the assign the right symbol to the right numbers. So in this case, the larger number is going to take the minus, okay, because I want my answer to be negative. So if I multiply negative 3 times positive 2, I get negative 6. And negative 3 plus 2, I get negative 1, okay? And remember, you're going to do a t-chart, okay? And put all of them, each one equal to 0. So you're going to write 8 minus 3 equals 0, and x plus 2 equals 0. And because I don't have enough time, or I got enough space, so we're going to skip the other step, but you know that this x will come positive. So your first root becomes positive 3, and this 2 will become negative. So I have my 2 roots now, okay? Bubbles, and the only thing you have to do is make sure you change the signs. So now, because we have the 2 values of x, now we're going to find the 2 values of y. And we're going to do exactly the same thing we did on the do now. We're going to use the linear equation. So the linear equation here is y equals 3x plus 5. So that is the one that I'm going to use. So I'm going to write here y equals 3x plus 5. Okay. Here and here, because I have to do it twice. It's going to be a little lengthy, this lesson. That's what I'm going to give you times to digest. So now you're going to have y equals 3 parentheses the value of x, which is 3 plus 5. 3 times 3 is 9, and 9 plus 5 is 14. So your first solution is 3 comma 14. Remember, x comes before y always. So same thing here. Y equals 3. Now the value of x is negative 2 plus 5, right? What did I put 1? So it's plus 5, my bad. So when I multiply 3 times negative 2, I get negative 6 plus 5, all right? So negative 6 plus 5 will give you negative 1. So I think I made a mistake here. So this one is negative 1. So when x is negative 2, y is -1. All right? So remember, we don't have to check on this one, okay? Because, you know, I just want to make sure you don't forget, okay, that if we ask you to check, you have to check. So let's move on to problem number 3, all right? Number 3, right? Y equals x squared minus 6x plus 5. 2x plus y equals 5. Remember, guys, in this case, the line is not, the y is not isolated on my linear equation. So what I have to do, you know that, right? Solve for y. So we're going to move this 2x to the right side, right? To leave the y alone. And I will have y equals, that becomes negative 2x plus 5. And now that I have my two equations with the y isolated, I can set equal to each other, okay? Okay, set equal to each other. Or remember, this y right here, we're going to substitute for this value right here. Not the value for that trinomial or that equation right there. So I'm going to write x squared minus 6x plus 5 equals negative 2x plus 5. If you know what I'm doing, I'm just putting this equals to that. So, of course, we're going to put it equal to 0 because we have to set it up equal to 0. And we'll do the opposite. That's minus becomes plus, that's plus becomes minus. And, of course, that becomes 0 on that side. When I combine line terms, I'm having x squared, negative 6 plus 2 is negative 4x, and my 5 cancel out because 5 minus 5 is 0. So this one is an incomplete quadratic. So incomplete quadratic because I still have the linear term, I can use the GCF. So my GCF is going to be x. So if I divide by x, okay, so the x goes out and I will have left inside x minus 4 equals 0. Now remember, we do our t-chart, right? So this x be equal to 0. And that x minus 4 equals to 0. I'm sorry about, if you don't have enough space, but that's what I'm going slow. Okay, so you can follow me, all right? And I set up my table better because I'm learning, okay? So now that means that this first root is going to be 0 because x equals 0. Remember, whatever is an x, you have to put them equal to 0. And that negative 4 becomes what? Positive 4. So I have my two values of x. Now I need to find the value of y, okay? So, like I said before, remember, you always want to use the linear value. And you have to use the one that's already isolated. So we're going to use this one, okay? So I'm going to copy y equals negative 2x plus 5. I'm going to do it twice because I have to do the process twice. I have to do it for each of the x values, all right? Now, I'm going to solve to find y. So y equals negative 2 parenthesis 0 because that's my value of x. So y equals 0 plus 5. So y equals 5. So when x is 0, y is 5. Remember, this one you can put in parentheses because this one are order pairs, okay? So let's find another solution, okay? The other value of y when x equals 4. Same process, okay? Y equals negative 2 parenthesis 4, that's my value of x, plus 5. That will be negative 8 plus 5, which gives me negative 3. That means that the next order pair is formed by the value of x, which is 4, and negative 3, which is the value of y that I just found by substituting. So we have done 3 problems. Remember, everything is the same thing. If the variable is not solved, so you have to make sure you isolate the variable so you can put them equals to each other, all right? So let's go on the back. So, like I said, the lesson is a little lengthy, but I'm doing it very, very slow, all right? So let's do this one. Okay, here, if you notice, all right, number 4, Both y's are already isolated. So what I'm going to do is I'm going to set them equal to each other. Remember, set equal to each other, because both y's are already alone, okay? Which is the same thing as substituting this y for this part right here of the first equation. So what I do, I bring down negative x squared plus 6x minus 1 equals x plus 3. Now, let's set it equal to 0, right? So that x becomes minus, the 3 becomes minus, and I must do the same thing on the other side, okay? So it's going to be minus x minus 3. Don't forget the negative or the first value, right? That's going to be something that we have to consider, because we're going to get the wrong answer if we do not bring down the negative. Okay, negative 1 minus 3 is negative 4. 6 minus 1 is 5. So now remember, when we factor, we always want the quadratic term to be positive. So what we have to do in this case is just divide everything by negative 1. Okay? If we divide everything by negative 1, the x squared becomes positive, the 5x becomes negative, 4 becomes positive now, and obviously 0 by negative 1 is 0. Then we're going to be able to factor now using regular factorization. So double bubble, same signs, because if the last one is positive, both bubbles take the middle sign turn, so they're both going to be negative, x and x, and 4 and 1, because negative 4 times negative 1 is positive 4, and negative 4 plus negative 1 is negative 5, okay? We do our t-chart, remember, you set equal to 0 each set of parentheses, and you know what's going to happen, okay? That's going to become positive 4, okay? So I'm going to continue here. So my first root is x equals 4, and my second root x equals positive 1, because this one going to be plus 1, and that's going to be plus 4, plus 1, plus 4, and plus 4, and that's where the 4 and the 1 comes from. My next step is to find the value of y, all right? So use the linear term. Remember, the linear equation always. If you want to use the parabola, you can. The quadratic, but it's going to be a little more, you're going to do more work. So, and you might be able to make a few more mistakes. So y equals, now this x becomes 4 plus 3, y equals 7. So my first order pair is 4, 7. That means that this line and that parabola crosses at that point, and also will crosses at this other point. When x is 1, I'm going to add 3, and that becomes 4. So that means that this graph, when I graph them, these two are system, is going to cross each other at point 4, 7 and 1, 4. All right. So let's do one more, okay? Two more, but this one is going to be a little more work, because you're going to see why, okay? Look, I have my first equation, which is the quadratic, which is the fraction, okay? 1/2 x squared minus 5x plus 2. Then I have the linear equation, which is not solved for, okay? The y is not isolated. So the first thing I have to do, isolate the y. So this y is going to travel to the right side of the equation, and I'm going to have left negative 2y equals negative x, because if it's positive, it becomes negative, plus 24. Now we'll divide everything by negative 2, right? So I will have y equals positive, because negative to negative is positive, 1/2 x minus 12, because 24 divided by negative 2 is negative 12. So now I have my y isolated. So now I can set these two equal to each other. Now I can put this one and this one equal to each other, okay? Or just substitute this y into this one. So it doesn't matter how interpreted, it is the same process. So I'm going to set equal to each other, this one with this one. So I'm going to write 1/2 x squared minus 5x plus 2, okay, which is my quadratic. Okay, it's my quadratic, equals my line that I already substitute, which is 1/2 x minus 12. Okay, so it's right here. I did 1/2 x minus 5x, square, plus 2 equals 1/2 x minus 12. This one is this right here, and this one is that one right there. Now you're probably asking where these two come from. Okay, remember, when we have a fraction, it doesn't matter if we have a fraction in this side or on the other side. Wherever you have a fraction, you can eliminate the denominator multiplying by the reciprocal. So in this case, to eliminate these two here in both sides of the equation, I'm going to multiply everything, both sides of the equation, times 2. All right? Everything. So I'm going to multiply this, everything, so I can eliminate those two, but you have to distribute, okay? I'm doing that. To eliminate fractions, multiply by the reciprocal, okay? So that's what I'm trying to write here. To eliminate fractions, multiply by the reciprocal. So when you do 2 times 2 is 2, and 2 divided by 2 is 1. So I'm going to have x squared left. 2 times negative 5 is negative 10x. 2 times 2 is positive 4. I go to the other side of the equation. 2 times 2 is 2. And 2 divided by 2 is 1. That's what I only remain the x alone. And 2 times negative 12 will give you negative 24. Now that I eliminate all my denominators, right, what I'm doing is I'm just going to put them equal to 0. So minus x plus 24 minus x plus 24. So obviously my right hand side becomes 0 because those two cancel, right? And in this side I will have x squared minus 11x plus 28. Double bubble, we have to factor now that we set it equal to 0 because the last one is positive. Both bubbles are going to take the middle term sign, so they're both going to be negative. X, and I will have 7 times 4. 7 times 4 is 28, and 7 plus 4 is 11. Remember, you have to set each one equal to 0. Okay, so that means that becomes plus 7, plus 7, plus 4, plus 4, and that's where this 2 roots comes, all right? So we want to continue here. I think I'm doing better now because I'm going slower, all right? So you don't have to, let me just double page here so you can have better. Okay, I want to drop the phone because I did that yesterday and it was a chaos. In the middle of recording, my phone fell. All right, so look. So remember, from here, we went all the way to here. Let me just. So I have x equals 7 and I have x equals 4, okay? That comes from here, from my roots. So what am I going to do now? I'm going to find the value of y. How am I going to find the value of y? By using my line, okay? Remember, this is the line here, the equation of the line. When I solve for y, it's easier to solve the one that you already isolate. So y equals 1/2 x minus 12, twice because I got to do it 2 times. And I'm going to use 7 here as x and 4 here as x. So 1 equals 1/2 parenthesis 7 minus 12. 1/2 of 7 is 3.5 minus 12. And 3.5 minus 12 is going to give you negative 8.5. So your first point solution is going to be 7 comma negative 8.5. Same thing with the 4. Okay? Y equals 1/2 of 4 minus 12. Remember, guys, when you're doing the lesson, I hope you're pausing, okay, the video so you can do the process with me. Y equals 2 minus 12, so y equals negative 10, right? So the next point of solution, the second one is going to be 4 comma negative 10. Okay, a little work, all right? But that's what it is, all right, guys? And remember, do the lesson as many times as you want, okay? And the last one, we have a word problem here. I used two good friends, okay, two of my favorite students, ha ha ha. When Sophia and Nayeli fought each other at school, haha, it's a joke, guys. When Sophia and Nayeli ripped my shirt off, all right? Another joke, laugh. Okay, now let's get serious. When Sophia and Nayeli tried to solve the following system of equations, Sophia said that there are infinite solutions, and Nayeli said that there are no real solutions. Which student is correct? Explain. Okay, so they never agree in everything, all right? So remember, my two y's are already isolated. So let's set them equal to each other. Remember, set equal to each other. So that means that this y becomes that, okay? So I'm gonna write 2x squared minus 2x plus 3 equals negative 2x minus 3. And let's set it equal to 0, all right? So what's happening now is I'm gonna do plus 2x plus 3 plus 2x plus 3. So this side becomes 0. And look what happened here. I'm going to bring down my 2x squared. 2 minus 2 is 0 because they're different signs. And 3 plus 3 is 6. So that becomes an incomplete quadratic. Okay? So incomplete quadratic because I don't have the x value. I can use square root method. So what I'm going to do, I'm going to do minus 6 in both sides. Now, if that would have x like the one we did before, you have to use the GCF, okay? So my 6 disappear and I have 2x squared equals negative 6. Now, I divide by 2, I will have x squared equals negative 3. And if I do square root, look what happened. Look what happened. I will have x equals plus minus radical negative 3. We can't have negatives on the radicals, all right? So that means that Nayeli is right because the roots are imaginary, okay? So if you notice, I got here Nayeli because the roots are imaginary, okay? Every time you have, like, you remember the discriminant is the number inside the radical. When you have something negative on the radical, there's no real solution. So therefore, okay, there are not real solutions. Okay? So there are not real solutions. So that concludes the lesson. Remember, the homework is only 3 problems. And again, guys, you have 2 days to do this lesson. So you can do it, you can watch it tomorrow as many times as you can until you get the hint of it. And your homework is not going to be due until, so that was tomorrow, Tuesday, Wednesday, it's going to be due Thursday, all right? Thursday, so I'm going to post your new lesson on Wednesday. So tomorrow I'm not going to post another lesson because you're going to be working on this one Tuesday and Wednesday, all right? Thank you, have a nice evening.